Welcome to lecture number 28 for ECE 476 Advanced Embedded Systems, Touchscreens. Now the 52 Pi board has got a touchscreen that's actually pretty easy to use. We're going to be looking at a couple different programs. Here's one. I can set the color, red, green, blue, by touching the screen. So if I want to have different combinations of red and green, see what they are, use little sliders. That's one program we'll look at. Here's another program. This is Draw Poker. I can pick which cards I want to get rid of. So let's suppose I want to go for a flush. I'll get rid of these two cards and draw a new hand. And I didn't get a flush. Third program we'll look at is the game Yahtzee. So if I'm happy with my hand, I'll do a new roll. There's my die rolls. Let's see, 1, 2, 3, 4, 5. That's a pretty good roll. Let's try again. I'll keep that one. 2 ones, not a great name. Okay, so let's get rid of the 1, 2, 1, 4, and re-roll the dice. That's my second roll. Keep the 5s, get rid of the 3 and the 1. Third roll. Okay, I got 3 5s. All done with the touchscreen. And the last one we'll look at is using the touchpad as a numeric keypad. So I'm going to put the numbers 1, 2, 3, enter, 4, 5, 6, enter, 7, 4, 5, change my mind, 7, 8, 9, 1, 2, 3, enter. How do I use numeric keypad? So the stuff we'll look at with the touchscreen. Finally, we'll look at turning your Pi Pico into an RPN calculator. So I want to say, what is 17 ohms in parallel with 25 ohms? I would say 17, take the inverse, 25, try again. 25, take the inverse, add them, take the inverse. Answer is 10.119 ohms. How to use the touchscreen with your Raspberry Pi Pico. So starting out, the graphics display includes both graphics as well as resistive touchscreen. With a touch input point, you can set it up so the XY coordinates of the screen match the graphics window, meaning the upper left corner is 0, 0, the lower right is 479, 319. Multiple touch points are supported. In theory, interrupts can be used for setting up when you use the touchscreen. In the following code, we're just using polling. Each time I call the touch.readPoints, the number of touch points is returned along with the XY coordinates of each touch point. The topics we'll be covering is how to display the XY location of up to 3 touch points, using a slider bar to change the RGB colors, playing draw poker, and using a numeric keypad. The base code comes from MicroPython libraries, and here's the link. In order to get this to work on your board, you got to download the GT911 library. So on your Pico board, if I stop it and do File, Open, on your Raspberry Pi Pico, there needs to be GT911.py. The base code is on Bison Academy. Well, it's there. So let's start with the base code. The base code just sets up the touchpad, initializes it. This is how many touch points you're allowed. Here's the refresh rate. And then to read it, I will just read touch points or read points from my library touch. That's your touchscreen library. You got to import that. This is the instance of a touchscreen. This is how many touch points I have and the location. I'll display how many touch points along with the XY spot, and here's what that code looks like. So as I run it, it's waiting for me to touch the screen. There's actually nothing on the screen right now, it's just location. If I touch it, there's the location. As I move my pen around, this gives the XY location of that touch point. If I have 2 touch points, I get 2 spots, 3 touch points. The number of touch points allowed is set up right here. how many touch points you allow. So this is kind of the base code. The upper left corner is 0, 0. This is 479, 0. And the lower right corner is 479, 319. I return 0, 0 when the screen is not being touched. With that, I can start doing things like let's build a slider. So here's what that code looks like. I've got red, green, blue. If I touch it, this is how much blue I have. This is no blue, brighter and brighter, getting up to 255. This is the green content. Change with the slider. Here's the red content. So when I have less green, more blue, maybe a little bit less blue, a little bit less red. That's what the program does. So let's see how that works. In the code, I'm going to check using polling, am I touching the screen? If I am touching the screen, meaning there's more than 0 touch points, I'll pull out the XY coordinate of where I'm touching and then check. If the Y coordinate, this is 0 to 100, and over here, that's interpreted as red. That's changing the red color. If I'm between 100 and 200, that's interpreted as green. If I'm between 200 and higher, that's called blue. I will then make the level the X coordinate minus 50. So over here, 0 to 50 is 0. Beyond 50 is where it starts recognizing it. That distance is the color clipped at 250. That'll be the red, green, blue. Draw a box. Well, first I clear out the old box, redraw the box in black. It just speeds up the animation a little bit. Recalculate the position, draw the new box in blue. And then set the color to red, green, blue, and draw a solid box over here. So that's kind of what the program does. Here's the contents of green, blue, red, and what the color combination works out to. And kind of a touchscreen used as a slider. Second program. Let's look at Draw Poker. Now, Draw Poker, what's going to happen is every time I hit deal, I get a double beep saying that I acknowledge that. I'll deal out the cards. It's kind of washed out. You can zoom in, you can kind of see that. You can decide what you want to do in poker. Let's, kind of lousy poker hand. Let's just keep the king, get rid of everyone else. I'll just tap the cards I want to get rid of, hit draw. I get a beep that says I succeeded, I drew a new hand, and I've got a pair of kings. This actually lets you cheat. Yeah, I want to draw again. Keep the 2 kings. Yeah, I still have crap. Try again. New deal. I've got pair of kings, maybe a flush. Let's keep the 2 kings. Draw. And I've got 2 pair. Okay, let's see how that code works. The game starts by shuffling the deck. That's calling lcd.shuffle from the LCD routines. Start with the 0, 5 cards in your hand. Value and suit is just a 5x1 array. Take the first 5 cards in the deck and deal them out to your hand. Calculate the value. That's the hand mod 13 plus 1. So the value is 1 through 13. The suit is hand over 13 plus 1. And then the card is, I'll display the value of the card, 1 through 13, ace through king, the suit, 1 through 4, at this location. So first card, each card is 75 pixels over. I'll then have a text, deal, and draw. That just kind of sets it up. When I have a new deal, that's what I get. That's kind of the base. Next, I want to be able to select which cards I pull. So I've got these 5 different regions. If I click on the different regions, that kind of toggles it on and off. Let's put it over here so you can see it. There's a green star that's toggling on and off. A green star means I want to discard that card. The way it does it is it checks for your touch point. Let's see. If the touch point would be fields 0, 1, 2, 3, 4. That part does. The card, this card 0, 1, 2, 3, 4. Can't be less than 0, can't be more than 4. And checks if the Y value is between 0 and 150, somewhere over here, it accepts it. And when I accept it, the flag draw becomes 1 or 0. 1 means I want to draw it, 0 means don't draw it. If I click on draw, it's going to check every card that's got a star over it. I'll replace it with the top card in the deck and move the pointer to the next card in the deck. I'll beep once to say I acknowledge the draw. If I click over here between 50 and 150x, 200 and 250y, that says draw a new hand, I beep twice. And the net result is I can kind of play poker. Now this code doesn't tell you what your hand is or how many points you get. That could be left for a homework assignment. For example, let's go for a flush. I'm going to get rid of those 2 cards, draw, and I didn't get it. Next program. Turn your Raspberry Pi Pico into a numeric keypad. So this is actually like the 4th version of it, kind of what I settled on. This lets me input numbers like 4, 5, 6, push that on the stack, 7, 8, 9, push that on the stack, 4, 2, 1. If you change your mind, clear, pulls out the last digit. Let's try another one. All this does is take numbers and push it onto a stack. What you do with it is left as a homework assignment or some other thing. You could play Mastermind, build an RPN calculator, stuff like that. How does this program work? Well, this actually has a couple subroutines I wound up using. One of them is place a button. I'm going to define, in this case, I've got a 6x4 keypad. I want to place a button at location BX, BY and give it a label. So like this would be a 4x6 keypad. This is key number 0, 1, 2. X is 3, Y is 0. So 3, 0 is the number 1. What that does is determines how long your label is, and then puts half to the left, half to the right, and it kind of centers each label on your screen, on the button. The x-coordinate is 480 divided by how many rows you have, or how many columns. The y-coordinate is 320 divided by how many rows you have. The location, the base location, upper left corner, is your key that you're talking about times SX, key that you're talking about times SY. So that'll be this spot right here. I'll then draw a box at that spot. Going to the right, by the length of one box. So draw a rectangle and then put in a label which you want to put in there. So here the labels are 1, 2, 3, 4, 5, 6, 7, 8, 9, clear, 0, enter. That's place button. The way I draw the keypad, this is another subroutine. When I first start up the code, put over here. If I start the program, stop, run it, it draws the keypad. So what that does is I'm going to draw a 6x4 keypad. This sets the one box in the X direction, one box in the Y direction. Draw the XY grid in gray lines. That's just for debugging, so I know where the keys are. Draw the horizontals, verticals for the lines, and then place the buttons. So I want to place the button at 3, 0, labeled 1. And this is again is a 4x3, a 6x4 keypad. Here's a 1, 2, 3, 4, 5, 6, 7, 8, 9, clear, 0, enter. Call the subroutine and this appears. Next, I want to read the keypad. When I hit it, what was the XY value of that number? So what this will do is I'm going to tell it this is a 6x4 keypad. I tap the screen. Which button did I push? It's going to return the touch point XY. So this is 6x4, the number 0 through 5, number 0 through 3. What is the XY location of the field that I tapped? So it's going to pull off just the first point, wait 30 milliseconds. What I want is I want to tap it, then release. I get a single read per tap. Pull out the XY location. Wait until I release. Then return the XY location. And this is scaled by the scaling X, scaling Y. So I get, for a 6x4 keypad, numbers 0 through 5, 0 through 4. Tells me which button I pushed. Then the main routine is an infinite loop. It just says I'm going to read the keypad, which button did I push? Then a whole bunch of if statements. If it was first row, third column, it was a 1. 0th row, fourth column, 2. 0th row, fifth column, 3. And so on, 4, 5, 6, 7, 8, 9, clear, enter. What do you do for each one? For the numbers, the new value of the number is the old value times 10 plus 1, times 10 plus 2, times 10 plus 3 gives you this. So do the number 1. 0 times 10 plus 1 is 1. 1 times 10 plus 2 is 12. 123. 1, 2, 3, 4. 1, 2, 3, 5. And so on. And once you have that, you could add other keys, build a calculator, do whatever you want. So to illustrate what's happening, here's the routine in Thani. I just ran it. That cleared the screen, sets the XYZ T to 0. That's my stack. Clears it. When I hit this spot right here, it returns the number 3, 0. That would be 0, 1, 2, 3, column 3, row 0. SY location. This is right here, 4, 1, 5, 2. What the sleeps do up here in read key, that's kind of trial and error. What I want to get is I only get one response every time it hit the button. If I hit over here, I get 1, 2, 0, 2. These are the different spots on the screen. Different keypads. The way the code is written, nothing happens in that case. So it read the keypad, I hit the key, 0, 2. 0, 2 doesn't do anything. It's only these keys over here that are recognized. And then enter. Well, this is clear. Clear does an integer divide by 10, pulls off a digit. Enter is a push. X becomes 0. X goes to Y, Y goes to Z, Z goes to T. And the purpose of flag is just to speed up the code. This routine is actually fairly slow. You can see when I update the screen, it takes a bit of time to draw it out. What the flag does is it leaves the buttons, the numbers that are unchanged alone, doesn't redraw them, only redraws X. Speeds it up a little bit. So that, in a nutshell, is the touchscreen. It's actually pretty darn easy to use. When you touch the screen, you return the XY location of the point. As you hold the point down, I get the same point over and over again. I get multiple reads. But with a little bit of software, I can see that if the point isn't changing, or changes by a small amount, I'll ignore it. Only larger changes or touch release is acknowledged, like the last program. Okay, so let's have some fun. Let's program a... Finally, let's turn your Pico board into an RPN calculator. So this is the same as the keypad routine, but when I hit different buttons, I'll do operations. So this uses a stack, X, Y, Z, T, and when I hit a button like 1, it takes the old number times 10 plus 1. Likewise, here's the number 1, 2, 3. That's just showing up for the different spots on the keyboard. So if I want to add numbers, like what is 17, enter, add 23 to it. 17 plus 23 is 40, divided by 6. It is an automatic push. Oops. I'll try again. So we do 17 plus 23, 23 plus, divided by 7. Or I could do resistors in parallel. What is 18 ohms? Take its inverse in parallel with 25 ohms. Add those, take the inverse. 18 in parallel with 25 is 10.4651 ohms. Okay, for example, let's find the resistance of this circuit using this RPN calculator. I'll start by clearing the X register. I want to add 300 and 200 in series. So here's 300. Push that on the stack. 200. When I add X and Y. 500 ohms. In parallel with 450, take the inverse. 450. Inverse. Add the inverses. Take the inverse. This is 236 ohms. In series with 75. This is 311 ohms. In parallel with 250. In parallel, you take the inverse, 250. Take the inverse, add the inverses, invert. This is 138 ohms. In series with 50. Totals 188.75 ohms. Stuff you can do with the touchscreen and the Pi Pico. Each time you call touch read points, I get a number. Each time I call read keypad, it waits until you touch, then release the screen, and returns the XY location of the corresponding key. And with that, what you do with the touchpad is really up to you, limited only by the imagination of the programmer. So that's lecture number 28 for Advanced Embedded, the touchscreen.